Let's deal with three dimensions. Basically, you need a length, you need a width, and you need a height. Now, not all these dimensions are measured as length, width, and height, but basically that's what we deal with. Okay? If you are talking about finding the volume of a prism, and the prisms that we are talking about would be like of boxes or things that you can turn so that they look like a box or various things like that. Enclosed rectangular figures. The basic formula for finding the volume of a prism is a big B times the H, where the big B is the area of the base. And how many bases do you have to have in order to do this? They have to have the same base on top and bottom. Now, why do I make a statement such as that? Because if you look at page 25 of the sheet that I handed out to you,
I can find my sheet.
if you look at 25 and you look at the figure that's here under example 2, if you look at that, it is a trapezoidal figure, correct? Remember we had problems with that when we did it surface areas? We have to have the same base, both top and bottom, that it sits on in order to find the volume. In this case, the base is the trapezoid down below and up above. Okay?
Yeah.
I don't know what you did with it.
I got that instead of
Okay? Does that make sense? That it has to be the same on both the top and the bottom, what it's sitting on, in order to be classified as the area of the base. So if I looked at, on the page that I just gave you, page 25, and I looked at problem number 1, and actually I have a cube on problem number 1, wouldn't you agree?
Oh, yeah.
Okay? If I wanted to find the area of the base, isn't the area of the base an 8 by 8 figure? So if I was finding the volume, 8 times 8 is 64, so I'd have 64. And what is the height of that cube?
8. No.
Times 8.
Yeah, 8.
So the volume,
12.
and in this case, when you're talking about volume, it's measured in cubic dimensions. Okay, so we're all right with problem number 1, with finding a cube. But let's go to problem number, what? Volume was equal to 8 times 8, which was the area of the base, times the height, which was 8. If I looked at problem number 2,
No, I can't remember the time it wasn't.
2. If I am trying to find the volume of that cube, is it setting on a base?
Yeah.
Well, no.
So where is my base going to be at in that problem?
The front.
Actually, it needs to be turned upright then, correct?
No.
So if I am using the basic formula of the area of the base times the height, in that particular one, I am going to be finding the area of a triangle for the area of the base, which in this case would be 1/2 small b times h times the h of the entire figure. Does that make sense? So if I'm looking at finding the volume of that particular problem, what is the base of the triangle?
Well, do you still have to have two bases?
They have to match.
So it'd be the front of it and the back of it. It wouldn't be what it's laying on.
Okay, that's correct. So what's the length of the base of the triangle?
3,
What is the height of the triangle?
1.5.
Yep. And what is the height of that entire figure?
4.
So I'd have to multiply all of those together. So half of 4 is 2, 2 times 3 is 6, 6 times 1.5 would be 9 centimeters cubed.
That was a little while.
Times, okay, so it's half of base times height, times height.
Since the base is a triangle, this becomes finding the area of the base. 1/2 the length of the base of the triangle times the height of the triangle times the height of the whole figure, which is 4. In other words, the distance from one base to the other base, if I looked, isn't that 4 centimeters?
Yeah, I didn't know, like, I knew
Yep.
what we were doing, I just didn't know what you wrote down for it.
We okay? So look at problem number 3. On problem number 3. Again, you have a prism. What is the shape of the base in that prism?
Triangle. Right triangle.
So to find the area of the base, it's 1/2 the length of the base of the triangle times the height of the triangle times the height of the entire figure. In other words, the distance from one base to the other. What is the length of the base of the triangle?
10.4.
How do you know it's 10.4?
3069 triangle.
Okay? In that particular figure, this figure right here, the length of the base would be from this point to this point in that triangle, correct? And the only dimension that you have right now is from here to here, which happens to be 12, which is the hypotenuse. Okay? I'm going to need to know this dimension from here to here, this dimension from here to here for that triangle. Well, isn't this the short side? Because it's opposite the 30-degree angle. How do I find the length of the measure of the short side in a 30, 60, 90? It's half the hypotenuse. So out here I'd have 6. The other leg is the square root of 3 times bigger than the short leg, isn't it? So what's 6 the square root of 3 is 10.4.
If we wouldn't have the hypotenuse, how would you find the hypotenuse? And what's the length?
It's 2 times the length of the shorter leg in a 30, 60, 90 triangle. Okay? The other way of finding this would be, I needed to know this side over here. Agreed? And you have an angle and you have a hypotenuse. How is this side related to the 30 degrees? opposite, and this is the hypotenuse. What function relates opposite and hypotenuse?
Side.
So I could go sine of 30 degrees equals the short side over 12. And what's the sine of 30 degrees?
0.5.
So I'd have 0.5 equals short side over 12, so the short side would equal 6. How can I find the longer leg? Well, how does the longer leg compare to the 30-degree angle?
Adjacent.
And you have the hypotenuse, so what function relates adjacent and hypotenuse?
You could also do Pythagorean theorem.
Could do Pythagorean's theorem. But why did I choose this 12 and this? Because 12 is given to me as a whole number, isn't it? So what function relates the long leg and the hypotenuse? So the cosine of 30 degrees would equal the long leg over 12. What's the cosine of 30?
0.5.
Can't be.
Oh, sorry, 0.87.
0.866 equals the long leg over 12. So the long leg would be approximately 12.4.
10.
Right? Why did I go through doing it this way with sines and cosine? What if this wasn't a 30, 60, 90 triangle? Let's say this was 40 degrees.
You'd have to do it.
Then I'd have to do the sine and the cosine functions, right? Okay? So back to the problem. We said the base was 10.4. The height of that triangle was 6. What is the height of the entire figure? 15. That is the distance from one base to the other base.
And that would be, I don't think it's right.
So I'd have half of 6, which is 3. 3 times 15 is 45. 45 times 10.4.
467.7.
You understand what I did? I took half of 6, which is 3. 3 times 15 is 45. 45 times 10.4. Did everybody get 467.7?
Yeah.
Okay?
Thanks.
Yes.
Yes, it was.